You've built a complete desktop application with live data simulation, real-time UI updates, data visualization, transaction logging, theme switching, file persistence, and CSV export. This single Java file demonstrates swing tables with custom renderers or custom painting for charts. You can extend it with real API data, additional chart types, or portfolio optimization algorithms. The foundation is solid and professional. We start with stock holding, the core data class. Each holding stores the ticker symbol, company name, number of shares, purchase price, current price, and purchase date. It has calculated getters. Get total value returns shares times current price, get total cost returns shares times purchase price, get profit loss returns the difference, and get profit loss percent returns the percentage gain or loss. The get sector method maps tickers to industry sectors using a simple lookup table, technology, finance, healthcare, etc. The current price is mutable because we'll update it with our simulator. The mainframe class holds a list for the portfolio, a list for transaction logs, a double for cash balance starting at $100,000, a random for price simulation, a scheduled executor service for the simulator thread, a boolean for dark theme, and a constant for the save file path. We also declare all the swing components we'll build, a table model, a table, labels for total value and day change, a text area for logs, a pie chart panel, and a theme combo box. The stock database is a linked hash map mapping tickers to company names and initial prices. The constructor sets the window title, size, and close operation. It calls load portfolio to restore saved data from disk, then builds the three main UI sections, the toolbar at the top, the main panel with the table and pie chart in the center, and the bottom panel with summary and log. It starts the price simulator that updates prices every 2 seconds, adds a window listener to save on exit, calls update UI to populate the table, and makes the frame visible. The toolbar has an Add Stock button that opens a dialog, a Remove button that sells the selected holding, an Export CSV button that writes to a file, and a theme combo box with dark and light option. Each button has an action listener that calls the appropriate method. The toolbar is set to non-floatable so it stays docked at the top. This gives users quick access to all major functions. The main panel uses a border layout. The center is a JTable with columns for ticker, company, shares, by price, current price, value, profit/loss percent, and sector. The table model overrides is cell editable to return false. This is read-only. We set row height to 25 pixels and disable column reordering. The profit/loss column uses a custom cell renderer that colors positive values green and negative values red. This gives instant visual feedback on which holdings are winning or losing. The right side of the main panel is a custom JPanel that overrides pink component to draw a sector allocation pie chart. It groups holdings by sector, calculates each sector's total value, and draws filled arcs proportional to the percentage. A legend is drawn to the right with colored squares and labels showing sector name and percentage. The chart uses anti-aliasing for smooth edges and cycles through 6 distinct colors. It only draws if the portfolio is not empty. The bottom panel has 2 parts. The top is a summary panel with 3 labels, total portfolio value, total profit/loss, colored green or red, and remaining cash. The bottom is a transaction log in a non-editable text area with a monospaced font, wrapped in a titled scroll pane. Every buy, sell, and load operation appends a timestamped entry. The caret is auto-scrolled to the bottom so new entries are always visible. The Add Stock dialog is a modal J dialog with a grid layout. It has a combo box pre-populated with the 10 stocks in our database. When the user selects a ticker, the company name and current price labels update automatically. There's a spinner for shares and a text field for the buy price, pre-filled with the current price. The Buy button checks if the user has enough cash, creates a stock holding, subtracts the cost from cash, logs the transaction, updates the UI, and closes the dialog. The Cancel button simply closes the dialog. The Remove method gets the selected row from the table. If no row is selected, it shows an error. If a row is selected, it shows a confirmation dialog with the sale proceeds. On confirmation, it adds the proceeds to cash, removes the holding from the portfolio, logs the sale, and refreshes the UI. This simulates selling a stock at its current market price. The price simulator runs in a single-threaded scheduled executor. Every 2 seconds, it iterates through all holdings and applies a random walk, a Gaussian random variable with mean 0 and standard deviation 0.5% is applied to each price. The new price is clamped above 1 cent and rounded to 2 decimal places. After updating, it calls swingUtilities.invokeLater to refresh the UI on the event dispatch thread. This creates the illusion of live market data. The update UI method clears the table and repopulates it from the portfolio list. Each holding is formatted with dollar signs and percentage signs. The summary labels are recalculated: total value, total profit/loss, and cash. The profit/loss label is colored green for positive and red for negative. The pie chart panel is repainted. This method is called after every buy, sell, and price update, keeping the entire interface synchronized with the data model. The log transaction method generates a timestamp using local datetime. It adds the formatted message to both the in-memory list and the text area. The text area's caret is moved to the end so the latest entry is visible. This provides an audit trail of every action taken in the application. The drawPieChart method uses graphics 2D with anti-aliasing. It first groups holdings by sector, summing their total values. It calculates the total portfolio value, then iterates through sectors drawing filled arcs. Each arc's angle is proportional to the sector's percentage of the total. A legend is drawn with colored rectangles and text labels. The chart is sized to fit within the panel's dimensions with room for the legend. The toggle theme method switches between dark and light modes. Dark mode uses dark gray backgrounds with light text. Light mode uses light gray backgrounds with dark text. It updates the background and foreground of the content pane, the table, including its header, the log area, the pie chart panel, and the summary labels. The theme selection is read from the combo box. Save Portfolio writes the cash balance and each holding's data, ticker, company, shares, purchase price, current price, to a text file. Load Portfolio reads the file back, restoring the cash balance and recreating all holdings. If the file doesn't exist, loading is skipped. The save is called automatically when the window is closed via the window listener. This means the user's portfolio survives application restarts. The export to CSV method opens a file chooser dialog for the user to select where to save. It writes a header row with all column names, then writes each holding as a comma-separated line. On success, it shows a confirmation dialog. On failure, it shows an error. This lets users export their portfolio to Excel or other spreadsheet applications. The main method uses swingUtilities.invokeLater to create the frame on the event dispatch thread. It attempts to set the cross-platform look and feel so the application looks native on Windows, Mac, or Linux. If that fails, it falls back to the default. Then it creates the stock Portfolio Manager instance, which launches the entire application. You've built a complete desktop application with live data simulation, real-time UI updates, data visualization, transaction logging, theme switching, file persistence, and CSV export. This single Java file demonstrates swing tables with custom renderers or custom painting for charts. You can extend it with real API data, additional chart types, or portfolio optimization algorithms. The foundation is solid and professional.